just a moment. All right, we're going to be doing something kind of interesting here tonight, and that is we're going to start looking towards our final project. Even though the end of the course is still several weeks away, we have a good roughly a month left before the class ends. One of the requirements in the class here as you work towards the end is completing this final project. I've released all the units at this point for the rest of the course, so you can work ahead. But I think it's important to be able to see that final project as you're working on it, especially considering it's a fairly large application to write. The thing that I would tell you about the project, and I know I was giving you some information prior to the recording starting this evening, is that this project is actually based on the official Oracle Java Level 1 programming certification process. So, basically, if you wanted to become a certified Java Level 1 programmer, you can study up. There's official tests that Oracle offers that you can take at official testing centers. And I just want to let you know Gateway is actually one of those official centers if you were interested. But it would take some study. There's some things we haven't covered that are part of that examination. But the examination that Oracle offers is basically split into two portions. One portion is taking a test. So you would answer, like we would have like a final exam or something. It is a lot more technical than my exams, by the way. So you would answer a series of questions, and if you pass that successfully, then they have you write an application. And this, at least, about 8 years ago, this was the official application as part of that exam. And I thought, what a better, Java 1 project to have than the same, thing that you would have to do on an Oracle certification exam, the same level of complexity. Now, the way that they present this to their audience, or the people that are basically taking it, is they do it in the form of a sample project for a high school programming class. And believe it or not, this is actually where the application was developed. So some of this reads a little bit like fiction or something, but it really is based on a real situation. So I'm going to bring up this document here and read through it. And there's kind of a little bit of a narrative that happens. And I know it's a little bit cumbersome for somebody to read you a document, especially in a situation like this. But I think it's helpful in several different ways. And so I'm going to read through this and kind of point out key things as we move along. And so here we go, folks. All right. So the application, or the document or whatever it is, called Your Vote Counts. So Mary Roberts is a senior who's always coming up with grandiose ideas that most of the class laugh off with an in your dreams kind of thing. She once tried to get the school board to include skateboarding as a requirement in the physical education program. And then there was a time when Mary proposed to have the AP Computer Science class try out for the real world. The more we put down Mary's ideas, the more encouragement she gets from Mr. Garcia, our AP Computer Science teacher. Mr. Garcia is forever telling us about these kids who revolutionized the entire computer industry, and they weren't much older than us. And folks, that's totally true. For example, 25 years ago, Larry Ellison saw an opportunity other companies missed, a concept for a database that no one else appreciated. You guys know who Larry Ellison is? Yeah, he's the owner of Oracle Corporation. He and his partner saw the potential and built it into Oracle Corporation, the biggest database software developer in the world. And then Mr. Garcia always follows the Oracle story by telling about how Bill Gates started Microsoft when he was still a teenager, not to mention the story about Wozniak and Jobs, two high school buddies who started Apple Computer in their parents' garage. Don't get me wrong, they're great stories, and I always bait Mr. Garcia into retelling them whenever I'm just not quite ready to submit homework. But nothing like that could happen to anyone in my AP Computer Science class. Of course, Mary sees things differently. Mary's philosophy is, why not? Why can't she build the next computer to revolutionize the industry? Why can't she write the program that is useful to a big corporation? Why can't she come up with an idea that rivals those of Oracle and Apple? In fact, Mary likes to run around quoting Larry Ellison, when you innovate, you've got to be prepared for everyone telling you you're nuts. And Mr. Garcia totally agrees with her. He has a point. Programs used by big corporations are written using the Java programming language, the same language that you guys are learning in school right now. I guess when you look at it, Mary and Mr. Garcia might be onto something. Those programs contain the same if statements, string objects, classes, and other syntax that we write in our programs. One day, Mary came up with this really way out idea. She thought high school students should voice their opinions on current affairs each week on the World News Network. Of course, CNN is really what they meant. Mary wrote to WNN with her idea and said our AP computer science class would write a Java program that collected votes from our student body, which she forwarded to WNN. Actually, Mr. Garcia came up with the idea that our AP computer science class would write the program. Weeks passed and even Mary forgot about the idea, but then her mom showed her a letter that arrived at noon. The return address was WNN. WNN. I dropped if WNN responded to my letter, but the letter didn't exactly excite Mary. Companies were always sending Mary official-looking letters that basically said, loved your idea, but not right for us. Keep up the good work. However, this was a little bit different. WNN did write, loved your idea, but didn't say not right for us. In fact, they countered Mary's idea proposal with one of their own. This was the jaw dropper that had both Mary and her mom reading the letter over and over again. Yes, they agreed with Mary that high school students should have a stronger voice and that Mary's weekly surveys were a good way for people to make their voices heard. WNN proposed to give each student who worked on the survey program a grant towards his or her college fund and give a grant to the school to fund new computers for the AP computer science classes. But there was a catch. The class had to write the survey program. The survey program had to work perfectly. And if we succeeded, WNN planned to distribute the program to all high schools that participated in the survey. Part 1, writing a program outline. The AP Computer Science class was ecstatic when Mary broke the news. Writing a Java program for WNN and getting paid too. Mr. Garcia was just as excited as Mary was, but more contained. He just couldn't wait to burst out and blab the secret. Is it true, Mr. Garcia? Yes, I also received a letter from public relations staff of WNN. They want the class to build a survey system so high school students can vote for their favorite WNN performer. You could see how proud he was of Mary and our class. I discussed the project with Dr. Allen, and she is allowing us to substitute the WNN project for our regular lessons for the remainder of the term. This means that we begin the project today. So how do we start this project? Julian cautiously asked. Let's see, Mr. Garcia answered. He took up his favorite position sitting on the corner of his desk. The WNN deal requires the class to design and write the program without any help from outside the class. So where should we begin? Well, Sherry paused. We'll at least need to know how the program is going to work. I mean, how can we be expected to write the program without knowing what WNN wants? Sherry asked a bit sarcastically. I mean, what's going to be on the screen? What are the kids expected to type? These are good questions, Sherry. Where are you going to find the answer to those questions? I guess we need a plan, an outline that describes how the program is supposed to work. Why don't we begin with an outline? Mr. Garcia went to the board and wrote, display, prompt, input, processing, and output. And I want you guys to notice these, so I'm breaking out of character here a little bit, but this is a real common thing. So we're going to put something on the screen. We're going to prompt the users to do something. They're going to give us some sort of input. We'll do some processing in the background, and then we put results back on the screen. Classic programming. Very sequential in its logic, and that's what they're identifying here. So what happens when someone starts the program? He turned and looked back at the class. Something appears on the screen, right? Correct, Mary. So this means we need to come up with something to show on the screen when the program begins. He pointed to the first item on the board. What's next? We have to tell the person taking the survey to type something. So you're telling me that you need to decide how to prompt the user to enter something. He points to the next item. Keep going. What happens next? The program does something with input. Good. It sounds like we're coming up with a plan. Mr. Garcia stopped to think. So I think you're saying that the information entered by the user needs to be processed. Mr. Garcia always had a way of correcting you without embarrassing you in front of the whole class. I wish I could learn that skill. And the last thing, his eyes focused, Sherry, the program displays the results of the processing. I'll buy that. Now that you have the outline for the project, write the specifications for the program. All right, and that's kind of the process that I use in class too. Is I read this through, we went to the whiteboard, and we started kind of building it. So here's the assignment. Before you begin writing the code, you need to have a plan, and I want to stress this because this is a little bit more complicated than just looping through and making a silly shape on the screen. So use the elements from Mr. Garcia's outline: display, prompt, input, processing, and output, and write an outline that will describe how your application will work. Right, so part 2, displaying the questions and the menu. We had to write a complete Java application that had to work perfectly. Otherwise, no WNN and no money. The class was baffled at first. We had never really built a real program that would be used by a major company. However, once we talked about how we want the program to work, we soon learned that we knew a lot. The more we talked, the more Mr. Garcia's outline made sense, and soon pieces of the WNN survey began to fit together. Okay, what's your next step? Okay, silence in the room. Just as everyone went out of the way to make eye contact, to not make eye contact with Mr. Garcia. Come on, the hard part's over. You know how the program will perform. Now you simply need to write the code. Right. There's nothing simple about writing code, though, right? I guess we begin with the first thing that we want the program to do, said Bob. So what's the first thing you want the Java program to do? Create a skeleton of a class. Do you know how to do that? Sure. How do you print text to the screen? Well, system out print line or J option pane. Right. Now suppose you want to store the text in memory before you display it. And this is what happens, when you start to problem solve, then you start to see how you know how to solve all the little pieces. And that's what they're really kind of pointing out here. It was like a sledgehammer hit everyone in the class all at once. You know the feeling. You spend half the class wondering what on earth the teacher is talking about, and then it clicks, pow, pieces fall into place, and you're a genius again. Well, that's what happened. We knew how to program, and we knew what we wanted on the screen. Now we just need to write the first screen that will be displayed. We need to create an object and variables and initialize them. Sounds like you know what to do next. Go do it. All right, so let's finish reading this. We're almost done, folks. Part 3, responding to the menu selection. Yo, Mr. Garcia, over here, we need a little help. What's the problem, Polly? We got the menu displayed, but it's not working the way we thought it would. There's not a keyboard read, and you have to restart the program every time you want to choose an item from the menu. That's right, so how are you going to fix that? Well, thinking through the problem together, what's the smallest problem? Reading the menu, select from the keyboard. What's the simplest way to do that? System in read. Okay, they're using a little different tools than we are. We use the scanner, whatever. Same basic difference. Is that the only way you know how to do that? No, we can use J option pane or buffer reader or the scanner or whatever. Okay, so what's the next problem? We have to know what the user selected. How do we do that? Well, with an if or switch statement, the class shouted. Of course they shouted. Next, the program will need to show something on the screen to respond to each menu selection, and then refresh the screen with the menu after you display a response on the screen. You want the next person to be able to make a selection with the menu without restarting the program. Sounds like a loop, right? Also, if there has to be a way to quit the program, something we kind of learned today too, and each separate function should be in a method. All right, part 4, create a method to tally the students' votes, and the totals are displayed for each menu item to tally the votes. Writing an opinion on the command line, create a method that enables someone to either display the default question in the list of options on the current affairs issue of the week on the menu, or enter a question and possible opinions at the command line. All right, and then finally, incorporating inheritance into the program, create a new class that contains the data to hold the totals for votes of each item, and then inherit its capability in another class. Now, that's the only piece that we haven't learned yet, but that's coming in an upcoming chapter, inheritance. And so this is kind of the roadmap here, folks. As primitive as this explanation is, it's kind of in a story-like format, but this is how they present it. And then people are, instructed on their own to conceive this and build it, but they're giving hints along the way. So what we did in the classroom, and I forget how long ago this was. This is probably, I'm going to say 2 years ago, 2.5 years ago, roughly, that we did this. So we sat in the class and we started talking about how the program might function. And so this is where we started. All right. If you sit down at the computer, you launch this program, it's going to put a menu up on the screen, and then you're going to be basically asked to like take a survey. If you can see the survey results, so there's a way to see the results of all the voting that happened. There should also be a menu option for being able to edit the content. So if you want to change the questions and the responses and clear the votes, there should be a system for doing that. But that should be password protected. And then an option to exit. So that should be the main screen. So if you think about it, from the user perspective, the first thing that happens is the menu gets displayed on the screen. The reality is, and what they were hinting to in that description, is before the menu displays, we will pre-create all the objects that we need to hold the answers, the questions, the vote tallies, and any other mechanism we need data-wise on the back end. And so that would actually be the first step programmatically. We'd pre-create all the default stuff and preload a survey, right? And what did I say? Instantiate and populate. Okay, that's what I said there. So then we put the menu on the screen. Then we get the input from the user. And depending on if the input is valid or not, right? If they give us invalid input, we would go false and loop back to put the menu back up on the screen again. If they give us the correct response, then we would branch to one of 3 different areas. So using that example that we just had, the 999 to exit. So one of the exit options would be that. Now, I don't think we're going to put 999 there. We could put 4, instead. But just to tie it into our lecture from earlier. So that would take us out. But if they did select 1, 2, or 3, and in this case, this would be like a switch statement or series of ifs, one of those, we would then branch to one of these 3 things on the board. So if they chose option 1, which is to take the survey, we would then display the questions on the screen and the possible answers. So they might say, like, who is your favorite news anchor? Joe, John, or Susie, or whoever. And then you make your selection. So you display the question and the answers on the screen. You get the input from the user selecting from the answers. So usually it'll be like a multiple choice question with one of several possible answers. You check to see if that input you got is valid. If not, display it again. If it is valid, then you tally the response. You just add it to a variable basically and go back to the main menu. Next person is ready to take the survey, right? If they chose option 2, that would show what the vote totals are. And so it would just display the question and the answers and show how many people voted for it. And then display the number of responses for each. And then it goes back to the main menu. So that would be if they hit option 2. If they hit option 3, then what will happen is they will go to the edit menu, and then they will be prompted for a password. So we're going to, think about, having a password protected. You don't want anybody to be able to edit your application or the questions or the answers. And so they would prompt for a password. If it's valid, they move on. If it's not, see the little false branch here? We'd give them 3 chances to try, and if they screw up 3 times, they're out. But if it's correct, then they display the edit menu. And then what you have here in the edit area is kind of like a microcosm of the whole program, right? So if we're going to be in the edit menu, we're going to basically get whatever their choice is. Like, which question do you want to edit? Is there 1 question or 5? You want to edit question 1 or 2 or 3? And then, once again, checking for valid input. If not valid, display the edit menu again. But let's say they selected question number 1. So now they're in the edit question mode. Then they can pick which question, type in the new 4 answers, clear the totals for the old question and answers. And then when they're done, they go back to the edit menu, and then there should be a way to exit from the edit menu back to the main application. All right. So that's kind of like a roadmap of the whole darn thing. In terms of the things that we're going to pre-create, we also kind of figured out that. So we would have basically integers to total how many for each answer would be set up. So we'd have answer 1, answer 2, answer 3, answer 4. We'd also have a class that pre-creates our questions and answers for us. And those things get pre-created as the application starts. So the question structure, answer structure, and the tally mechanism are all pre-created by the time the menu appears on the screen. And so while this seems very complicated, I want you to think about all the things we've already learned. The only thing that we haven't learned yet to help accomplish this is the concept of inheritance. Well, sort of, we haven't learned it. We've learned about classes and instantiating them. Now we need to learn how to inherit from a superclass. That, like I said, that is coming up. But now we know looping, decision making, how to put stuff on the screen, how to get input, how to do decisions, how to run a loop and all that stuff and keep an application running. We have all those pieces in place. So now if you start thinking about it that way and you're a good planner, this is our roadmap, folks. So this is something that we can use as a guide. All right, I'm going to stop the recording here. This is our kind of our preview of what we're about to do, but it's important to get started, which is why I'm happy we were able to get it going tonight.